The law of sines is a rule that we will use to solve triangles that are not right triangles. So we know that we can use right triangle trig, SOHCAHTOA, sine, cosine, and tangent when we're working with right triangles. But if we have a triangle where there are no right angles, then we have to use different rules. And the law of sines is one of those rules that we can use. Another rule that we can use is the law of cosines, which we will look at in the next section. But how you differentiate between whether you're going to use the law of sines, like we're going to do in this lesson, or the law of cosines, is it depends on what you know on the inside of the triangle. So I'm going to draw a line right here and separate the law of sines triangles from the law of cosines triangles. So let's look at what we know on the left side. So when we're working with triangles that can be solved with the law of sines, you'll notice that in each of these triangles, we have a corresponding pair of an angle and we know its opposite side. An angle and we know its opposite side. In the first case, it doesn't look as if we do immediately, but if you know A and you know B, then we could find this missing angle C, because we know that all of the angles in the triangle have to add up to 180, and then we have a pair of an angle and its opposite side. So when you have a pair, angle opposite side, then you can use law of sines. If you're working with a triangle where we don't have a pair, for example, in a side triangle, we don't have any of the angles, and in a side angle side triangle, we don't know what this side is, we don't know what those angles are, so there are no pairs. So when we have no pairs, we'll use law of cosines. Okay, so now we're going to go look at some examples showing how we use these two different versions of law of sines to solve triangle. In example 1, we are given a triangle to solve, so we want to find all of the missing values. So what's missing in this triangle is capital C, and little a. What we have in the triangle is capital A, capital B, and little b. Notice that we do have a pair of an angle and its opposite side. So the pair that we have is capital B and little b. The fact that we have a pair is what tells us to use law of sines. Because you have to remember, when you go on and take the test or the quiz, I'm not going to explicitly say use law of sines or use law of cosines. You might have to look at two different triangles and determine which one you want to use. And this is how you tell if you're going to use law of sines, if you have this pair. Okay, so now let's go on and start finding some of the missing values in this triangle. We could definitely solve for capital C very easily because we have the two other angles in the triangle, and we know that all of the angles in a triangle have to add up to 180 degrees. And so I'm going to just subtract the two angles that we were given, and that'll give us capital C. We still have to go on and find lowercase c and lowercase a, and this is where law of sines is going to come in. So I'm going to scroll up so we can look at the two different versions of law of sines. We're trying to solve for either little a or little c. I'm going to choose to solve for little c first. I'm going to choose the piece of law of sines that has little c in the numerator because that's what I want to solve for. So this whole piece of this ratio, I know I'm going to take in step 2 when I start writing my law of sines ratio. Now, what are we going to set that equal to? Well, we could choose to set it equal to either the b's, or we could choose to set it equal to the piece with the a's. Which piece we choose depends on which pair we know. And remember, we know a pair of the b's, and so I'm going to choose to set it equal to the version that has the b's. So that's how you determine how you set up your law of sines ratios. You definitely want to put what you're trying to solve for. Remember, we're trying to find little c, so I chose to put that piece. And then you want to use which pair you have, which is how we ended up with the b's. So now let's go ahead and start plugging into this. So little c is what we're trying to solve for. We know that capital C is 27 degrees. We can also look at the triangle and see that little b is 27 and that capital B is 105 degrees. So we've plugged everything in, and now in this equation to solve for little c, we need to get rid of that sine 27 that's in its denominator. So I'm going to multiply a sine of 27 degrees to both sides of this equation, particularly so that it will cancel on the left side and leave me with what little c is equal to. So now when we put this entire expression in our calculator for little c, we see that little c is approximately 12.7. Now we'll go on and use a different version of law of sines to solve for missing a. I'm going to choose now to involve a version of law of sines that has the little a in the numerator, so this version there, and I'm still going to set it equal to the b's because we know the b values exactly. I wouldn't want to choose to set it equal to the c's because little c is a rounded value, and I want to avoid using a rounded value when I'm trying to find a new value, just so we don't get any rounding errors. So we're trying to solve for little a, so I'm going to set that in the numerator, and I definitely know the b's, and so that's what I want to set this equal to. I'm going to go ahead and start plugging in what we know. Capital A is 48 degrees from the triangle, and we have the values of lowercase b and capital B from the triangle as well. Similarly, to isolate little a in this triangle, I want to get rid of that sine 48 degrees that's in its denominator. And so both sides of this equation are going to get multiplied by sine 48 to leave me with this exact value for little a. Little a is equal to 20.8. And now we have this triangle solved. Last thing I'll mention about this example is that I did not ever use any of these versions of law of sines because I was not trying to find capital A, capital B, or capital C in that triangle by using law of sines, right? It was really easy for us to find capital C. If I was trying to solve for an angle, I would have chosen one of the versions that had an angle in the numerator. Ultimately, it truly does not matter which version you choose. It just makes your algebra a little bit easier. In example 2, we want to solve a triangle with capital A equal to 32 degrees, B is 78 degrees, and little c is 57. I'm going to go ahead and set up a visual for that. Wherever I put little c, I need to make sure and put capital C opposite that. Wherever I put capital A, I need to make sure and put little a opposite that. And the same goes for capital B. So at first glance, there is no pair given in the triangle, but it would be very easy for us to solve for capital C because we know the other two angles in the triangle, just like in the first example. So now we have capital C. We still need to go on and find little a and little b. I'm going to start off and find little b. So I'm going to choose the version of law of sines that has the little b in the numerator. I can choose to either set that equal to the a's or the c's. And we're going to set it equal to the c's because we have a pair of c's. I'll go ahead and plug into this ratio. We're trying to solve for little b. We know that capital B is 78 degrees. We know that little c is 57, and we know that capital C is 70 degrees. To isolate little b in this equation, we'll need to come in and multiply both sides of this equation by a sine of 78 degrees, leaving us with little b being approximately 59.3 when we put this expression in the calculator. So now let's go on and find little a. I'm going to choose the version of law of sines that has the little a in the numerator. And I'm again going to set it equal to the c's because we know those exact values. We know that capital A is 32 degrees plugging into this. We also know that little c is 57 and that capital C is 70 degrees. Very similar to last time, to isolate little a in this equation, we're going to have to come in and multiply both sides of this equation by the sine 32 degrees that's in the denominator so that it will cancel. Leaving us with this expression to put into the calculator to find that little a is approximately 32.1. And now we have this triangle solved. So the things that examples 1 and 2 had in common is that it was very easy for us to find the missing angle. There was only one missing angle, and it was very easy for us to find because we already knew the other two angles in the triangle. In both cases, we already knew the other two angles in the triangle, so it was very easy for us to find the missing c. Once we had that, we had a pair, and we were able to use law of sines to solve for the missing sides. So again, we did not do any examples where we were missing an angle that we couldn't find immediately. When we look at examples where we're missing an angle, which is what we're going to do next, notice that to solve for a, b, and c, eventually we would have to use sine inverse to cancel out these signs. When we have to use sine inverse in order to solve, we have to pay attention to what sine inverse tells us and what sine inverse does not tell us. Because remember, the sine inverse function, the way that it works, is it takes in a y value that is between -1 and 1, right? Because that's the way the unit circle works. The unit circle does not have any y values that are smaller than -1. So it takes in one of these y values, and what it does is it puts out an angle with that y value. But not just any angle with that y value, right? Because say, for example, that this is the y value that we're talking about. But which angle is it going to give us? Because there's two angles that have that y value. There's this angle right here that has that y value, and then there's also this angle right here that has that y value. Both of those angles end at points that would have the correct y value. But we know that sine inverse has a range of -pi/2 to pi/2, which is -90 degrees to 90 degrees. So it's only going to give us an angle either that went backwards from 0 to -90 degrees, or forward from 0 one quadrant to +90 degrees. So in this case, it would give us the blue angle, the dark blue angle, this one. So we have to keep that in mind, because there's really two answers if we use sine inverse, but the calculator is only going to give us one. Okay, so let's jump in and look at some examples. Oh, and last thing, the calculator will only give us one if this is satisfied, right? Sine inverse does not return answers if you put in something that is smaller than -1 or bigger than +1. So it's possible that we get no answers. It's possible that we get only one answer, the blue answer that the calculator will give us in quadrant 1, or it's possible that there's really two answers, the light blue angle in quad 2 that the calculator does not give us. Okay, so looking at example 3, we want to solve this triangle. We are given some information about it. We do have a pair. We have capital A and we have little a. And I have little b. So the first thing that I'm going to choose to find is capital B, and then we can go on and find capital C and little c, maybe. So because I want to start off and find capital B, I'm going to choose the version of law of sines that has the capital B in the numerator. So notice now I'm choosing to use one from this side, and I've chosen this piece. And I'm also going to use it with the A's, because we have capital A and we have lowercase a in this triangle. So I'm going to choose to set this equal to sine of capital A over little a. Let's go ahead and start plugging things in. We don't know capital B. That's what we're trying to solve for. We do know that lowercase b is 38. We know that capital A is 28 degrees, and we know that little a is 12. Okay, so to solve for capital B, I first need to isolate this sine of capital B. I first need to get that by itself so we can use sine inverse. So let's come in and multiply both sides of this by 38, which would then leave me with sine of capital B alone and isolated on the left side of the equation is equal to 38 sine 28 degrees over 12. Now that we have the sine by itself and isolated, we can now come into both sides of this equation and cancel out the sine by using sine inverse. So everything that was on the right side of the equation is now inside of sine inverse. And the only thing we're left with on the left side of the equation is capital B, because the sine inverse and the sine cancel. Now, when we go into the calculator and we put sine inverse of 38 times sine 28 degrees over 12, do make sure your calculator is in degree mode. We're going to get a domain error because what we put in on the inside was bigger than 1. And it's not possible for the calculator to go and try to find an angle that landed on the unit circle where the y-coordinate was bigger than 1. So once we get that domain error, this triangle has no solution. So it is possible that you're given some values of a potential triangle and you start trying to solve it and you find that it's not possible to make a triangle with those specifications. Let's move on and look at example 4. So in this triangle, we are given a pair of capital C and little c. We need to find little b, capital A, and little a. I'm going to start off and look for capital B because we know little b. Because I'm going to start off looking for capital B, I'm going to choose to use the version of law of sines that has the capital B in the numerator. And I'm going to set this equal to the version with the c's. The piece with the c's, because we know both the c's. So let's start plugging in what we know. We know little b is 13. Capital C was given as 68 degrees and little c was given as 15. Similar process here. I need to isolate that sine b so that we can use sine inverse. So both sides of this equation need to get multiplied by 13 to get it out of the denominator. Now we're going to come into both sides of this equation with a sine inverse so that we can cancel out this sine. Sine inverse on the left and sine inverse on the right. The sine inverse on the right does not cancel. Okay, so don't try to cancel this sine inverse right there. That sign right there. It does not cancel. There's a lot of other stuff on the inside of this sine inverse with that sine 68 degrees. So when we put this in the calculator returns the capital B is approximately 53.5 degrees. So remember, we have to think about sine inverse in context, okay? Because the calculator does not tell the full story. So what the calculator is telling us is that at the angle of 53.5 degrees on the unit circle, I was able to find the y-coordinate that you asked me to look for. The y-coordinate that you asked me to look for. Because that angle, 53.5 degrees, was between negative 90 degrees and positive 90 degrees, which is the only place that I look. That's what sine inverse says. So we have to remember, well, what sine inverse is not going to look for in the calculator is this angle over here. That would also have the same y-coordinate that we asked the calculator to look for. Well, how could we find that purple angle? Well, looking at the picture, we know that there's symmetry in here. That purple angle is 180 degrees minus the 53.5 degrees that we had in the first quadrant, which leaves us with 126.5 degrees. So technically, when we evaluate sine inverse and the calculator gives us 53.5, there is the option that B could be 126.5, potentially. How we determine whether or not we're going to keep that option is we have to look at the fact that we already have 68 degrees on the inside of the triangle. We know that all of the angles in the triangle have to add up to 180 degrees. And if we take 68 degrees and we add it to 126.5 degrees, well, that's bigger than 180 degrees. So this is not possible. So it is possible that the only angle for B is what the calculator gave us. Because the calculator gave us that 53.5. We then had to go and explore to find that 126.5. When we find it, we say, okay, that is not possible. So we proceed with the only option for capital B being 53.5 degrees. From there, if we know that capital B is 53.5 degrees, well, we already knew that we had 68 degrees in the triangle. So we're then able to go on and find capital A because we know the other two angles in the triangle. So I'm going to subtract what we know from 180 degrees to find that capital A is 58.5 degrees. Now that we know capital A, we can now use a version of law of sines that has little a in the numerator. So now I'm using the version with little a on top because that's what I want to solve for. And I'm going to again set this equal to the pair that we know, which is the C's. I'm not going to use the rounded B value that we just found. So let's go ahead and start plugging in. I want to isolate little a, so I'm going to have to come in and multiply both sides of this equation by that sine 58.5 degrees that's in the denominator. And then when I put this exact value in the calculator, we find that little a is approximately 13.8. And then we have solved our triangle. So far in examples 3 and 4, we have seen examples now where we were missing angles, more than one angle. And we had to use sine inverse in order to start solving our triangle. In the first example, or in the first case, in number 3, when we used sine inverse, we got a domain error because we put something in that was bigger than 1. So we weren't even able to use sine inverse. That triangle had no solution. The second time when we had to use sine inverse, we were okay with the domain. What we put in was less than 1, so we were able to get an answer. Once we get the answer that the calculator gives us, we have to remember that the calculator is not going to return the second answer that is in quad 2 because it does not go past 90 degrees. We then have to use the symmetry, 180 minus what the calculator gave us to get the 126.5. Once we have that potential second angle, we need to look back at the angle that we started with, which was the 68 degrees, and say, is it even possible that the second angle in the triangle, capital B, is 126? In this case, it was not possible. In the next example that we look at, when we find this second angle, it will be possible. It will not be bigger than 180 degrees, and so we will end up with 2 solutions to that triangle. In example 5, we are missing the angle capital A, the angle capital C, and the side little c. I'm going to begin looking for capital A. So I'm going to start off with a capital A in the numerator. So I'm intentionally choosing this version of law of sines. And I'm going to pair this with the B's because the B is the pair of angle and opposite side that we know. I'll go ahead and plug into this. And then I'm going to isolate sine A by multiplying both sides of this by 18. And we'll need to use sine inverse on both sides of this equation to get capital A by itself. When we plug that into the calculator, we get that capital A is approximately 57.7. Same instance that we dealt with in the last case, we've used sine inverse, so we know that the calculator is not telling us the capital A could also be 180 degrees minus 57.7. Why? Again, quick picture. If this is 57.7 degrees, we got that answer because the y coordinate was what it was. Well, the y coordinate's the exact same thing over here. That second angle is 180 minus 57.7. So when we take 180 degrees and subtract 57.7, we get that the second possibility for capital A is 122.3 degrees. Is that possible? Is it possible that we started a triangle off with 28 degrees and find that the second angle is 123.3 degrees? That is possible, because if I take 28 degrees and add it to 122.3 degrees, I'm still less than 180 degrees. So we're able to pursue a second solution to this triangle. So the capital A that we're looking for has two options. One that I'll call capital A1, where capital A is 57.7 degrees, and another that I'll call capital A2, where capital A is 122.3 degrees. So we found the first part of what was missing, which are the two options for capital A. Now let's go on and find the two options for capital C. Well, in the first case, if capital A was 57.7, I would take the 180 degrees in the entire triangle and subtract the two angles that we already know, because we were given that capital B is 28 degrees. Which leaves us with 94.3 degrees for the first option of C. And we'll do the same thing on the other side to find the second option for C. But this time, we're going to make sure and subtract the 122.3 degrees. And now we have both options for what capital C could be. We're still missing the little c's, so this time we will set up law of sines, where a little c is in the numerator. And I'm going to again set it equal to the pair of b's, because remember, that's not a b1, that's just a little b. Because remember that we know exactly what the b's are. Go ahead and start plugging into this expression. I'm going to multiply both sides of this equation by the sine 94.3 degrees to get that by itself, which leaves me with little c1. The first option for little c1 is approximately 21.2. I've gone ahead and plugged into the other side for the second option for little c2. I'm going to multiply both sides of this equation to get that little c2 by itself, and find that little c2 is approximately 10.6. And now we have found capital A, capital C, and little c for both solutions of this triangle. So the moral of the story is that if you're using law of sines to find an angle, at the point where you use sine inverse, you have to remember that you get two options. You get what the calculator gives you, and then you also need to go and look at 180 minus what the calculator gave you. Once you get that second option, you have to go check, is it possible that that's the second angle in the triangle? Keep in mind what you already knew. If the sum of those two angles is less than 180, then you need to go ahead and pursue the second triangle. If when you subtracted what the calculator gave you from 180 and you got that second angle, when you add that to what you already knew in the triangle, if that's more than 180, then you need to stop and only go with the first angle that the calculator gave.